Now let us take some numerical examples on earthen dams. So the problem is like this. In order to find the factor of safety of downstream slope during steady seepage, the section of the dam was drawn to a scale of 1 centimeter is equal to 4 meter, and the following results were obtained on a critical slip circle. So here the slip circle analysis is done. This is the section of the dam given. This is the slip circle, and the different data obtained is like this. Area of n rectangle, that is equal to 14.4 cm square. What is the area of n rectangle? The normal component of the each slice is been obtained, and it is plotted graphically in the form of a rectangle. So that will give you the total sum of the normal component. So that area of n rectangle is 14.4 cm square, drawn to a scale of 1 centimeter equal to 4 meter. Now similarly, the area of T rectangle, T is the tangential component of the weight of the slice, and n is the normal component of the weight of the slice. So area of T rectangle is 6.4 cm square. Area of U rectangle, U stands for the uplift force, and its area is given as 4.9 cm square centimeter. Now length of the arc of slip circle. This is the slip circle around which the soil mass is going to slide, and the length of the arc of the slip circle obtained from the graph is 12.6 centimeter. So this is the data with reference to N, T, U and length of the slip circle. Other data which is given, that is the properties of the soil, is like this. The phi, angle of repose of the soil, phi is given as 26 degrees. The cohesion C of the soil is 19.5 kilonewton per meter square, and the unit weight of the soil is given as 19 kN per meter cube. Now, first of all, so to find out the normal component, actual weight of the normal component or actual normal component force, what we do is the area of this end rectangle will be multiplied by square of the scale, x square. X is the, if scale is 1 centimeter equal to x meter, then x square. So 1 centimeter equal to 4 meter is the scale. So 4 square into gamma w. Gamma, that is the bulk unit weight of the soil, which is given as 19 kN per meter cube. So here 14.4 into x square, that is 16, 4 square into 19. So that comes out to be 4377.6 kilonewton. So this is the total force, that is the normal component of the weight of all the slices. Then tangential component, sum of the tangential component of the weight of the slices, sigma t, that will be equal to similarly AT, that is area of T rectangle, into x square into unit weight of the soil. So this T is given as AT is given as 6.4 into square of the scale 16 into 19, that comes out to be 1945.6 kilonewton. Similarly, U rectangle, summation of U, that is pore water pressure, or what we can say as the uplift pressure, that will be area of U rectangle into x square into here gamma W, that is unit weight of the water, because it is pore water pressure, so we have to multiply it by unit weight of the water. So AU is given as 4.9 into 16 into 9.81, which comes out to be 769.104. Now the cohesion force, that is C into S. S is the length of the arc of a slip circle. C is the cohesion. Cohesion is given as 19.5 kilonewton per meter square into length of the arc. And now here the length of the arc is given as 12.6 centimeter, and the scale of the scale with which it is drawn is 1 centimeter equal to 4 meter. So for linear scale, 12.6 into 4, that will give the total length in meters, length of the arc in meters. That into 19.5 will give you the value of CS, which comes out to be 982.8 kilonewtons. Now The formula for factor of safety that we have already discussed for the stability of slopes of an earthen dam, that is summation of n minus u into tan phi plus cs upon sigma t. So we have already calculated sigma n minus u is the pore water pressure, into tan phi. Phi is 26, so tan of 26 plus c into s, which is this one, upon sigma t. So this comes out to be, so if we solve this comes out to be 1.39. That is the factor of safety obtained for this stability of downstream slope of an earthen dam. So this is the one type of numerical that you must know on earthen dam. Now let us take a second example related to quantity of seepage flow through an earthen dam. So let us take a second example related to seepage flow in an earthen dam. So the problem given is for an earthen dam of homogeneous section with a horizontal filter of 30 meter, if the coefficient of permeability of the soil material used in the dam is 5 into 10 raised to minus 4 centimeter per second, find the seepage per unit length of the dam. So here the section of the dam is given in the sketch. This is the horizontal filter of length 30 meter. The dam is homogeneous section with a maximum height of 20 meter. Top width is 6 meter. The upstream slope is 1 vertical to 4 horizontal. Downstream slope is 1 vertical to 3 horizontal. And the freeboard, that is the distance between the top of the dam and water level, that is given as 2 meter. So these are the details of the section of the dam given. Now here the seepage flow is given as Q is equal to K into Y0. Okay, now we have seen already that we have this base parabola with a equation of the base parabola that we have discussed, that is under root of x square plus y square is equal to x plus y0. Now what is y0? Y0 is this distance fh, that is the distance of the directrix of the parabola from the focus f of the parabola. So this distance fh is y0. Okay, now if we take any point P on the parabola, its coordinates with reference to f will be x, and y. Okay, so with these coordinates, this is the equation of this base parabola. This is the equation of the base parabola which we have already discussed. So from this equation we can find out y0 will be equal to under root of x square plus y square minus x. Now in this equation, to calculate y0, let us find out x and y values for a point B, which is a starting point of the base parabola. Now its y coordinate of the point B, that will be the height y of the water level, and which is given in this case as 18 meter. 18 meter because 20 meters is the height of the dam, minus 2 meter for pre-board, so that will be 20 minus 2, that is 18 meter. So that will be the y coordinate of the point B with respect to focus F. Similarly, x coordinate. Now we have to calculate the x coordinate of the B with reference to F. That is the distance FB dash is to be obtained. Now, as we have seen already that the distance from A to B is given as 0.3 times L, where L is this distance, that is the projection of the wetted length on the horizontal plane. So this height is 18 meters. So 18 with this slope as 1:4, this distance comes out to be 18 into 4, that is 72 meters, which will be the length L. So if this is L, the distance AB will be 0.3 L. AB will be 0.3 L. So AB will be equal to 0.3 into 72, that is 21.6 meter. Okay. Now the distance FB dash, so that will be calculated like this. We can find out the total base width of the dam. Now if I know this height is 20 meter, if this slope is 1:4, Then 20 into 4 will be the distance up to this face of the dam. So 20 into 4, that is 80 meter, plus this top width of the dam 6 meter, so 80 plus 6. Now the downstream slope is 1 vertical to 33 horizontal, so this will be this distance, horizontal distance will be 20 into 3, that is 60. So total base width will be 80 plus 6 plus 60, that is 146 meter. Now from this subtract the filter length, which is 30 meters. So 146 minus 30 minus, now subtract 72 from this, which will give me this distance. So this plus this remaining distance AB, which is already we have calculated as 21.6. So that will be, so the addition and subtraction of all this will give you 65.6, which is the distance FB dash, which is the x coordinate of this point B with reference to focus F. Okay, so after getting the x and y coordinates, we can calculate y0 by using the equation under root of x square plus y square minus x. So putting the values of x, y and x again, we get y0 is equal to 2.42 meters or 242 centimeters. Now, as we have already discussed, the discharge per meter length of the dam is given as K into y0. So y0 is calculated as 242 centimeters. The value of coefficient of permeability is given as 5 into 10 raised to minus 4 centimeter per second into the y0 distance. So that comes out to be 1210 into 10 raised to minus 4 centimeters cube per second. That is the discharge, seepage discharge for this dam. So this is the one type of example that you must know. Thank you.